Hello, assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. If you have been looking for a course that will teach you the practical takeaways of data analysis, okay, for scientific research, okay, it could be academic research that you are doing, and you want the course that will just give you the knowledge that you need and the skills that you need to be able to analyze your own data set and also analyze someone else's data set with confidence. This is the course for you. So in this course, I'm going to take you through the fundamental aspects, the things that you need to know to be able to analyze data, okay? So there are several lessons. So this is the first lesson, and we're going to begin at looking at the introduction to statistics. What preliminary statistical knowledge do you need to have before you can begin to analyze your data? So this is just a foundation lesson. So what are you expected to know? Your objectives are you'll be able to understand the basics of statistics and its importance in data science or data analysis. You'll be able to learn the types of statistics and the variables or data types. Okay, identify appropriate statistical tests for different data types. You'll be able to recognize assumptions and how to ensure that your data meets those assumptions before you can go ahead and use a particular statistical test. And then I will prepare you also for hands-on data analysis using SPSS and R. So what on earth is statistics? How do we define statistics? So statistics is a science, okay? It's a science, it's a branch of science that helps you to collect, analyze, interpret, and present your findings. You collect data, you analyze that data. The moment you collect that data, it doesn't have any meaning. It's just data, it's just raw data. No one can make sense out of it. But through data cleaning and analysis, you are summarizing that data so that anyone, even a layman, should be able to make sense out of your data. So that is what we call now statistics. So statistics helps to solve you problems such as, let us assume you are in a community. You are working as a healthcare provider at a community health post. You will realize that children between a certain age group are coming with diarrhea more often than previously. So there's an increased incidence of diarrhea cases among children of a certain age group. And you want to answer this question. So what are the steps that you're going to take? First, you need to generate a research question. What is leading to an increased incidence of diarrhea cases among this age group in this population, okay, or even the site? Once you come up with that, you have to write the research proposal, which is like a research protocol which guides you how you are going, what you want to solve, what problem do you want to solve, how do you intend to solve it, step by step, how are you going to adhere to the ethical guidelines. And then once you do that, you submit that research protocol to the ethical committee, okay, and the National Health Research Institute, something like that. Now, once you submit, they approve. Once they approve, you are going to be given an ethical clearance, which will enable you to start now collecting data. So you're going to go into that community, you collect the data, you analyze that data, okay? When you collect the data first, it will be very raw, so you have to clean it a bit, analyze, interpret, and present the findings. And that's what statistics is. Now, why is statistics important? It helps us to make informed decisions. It helps us to identify trends and patterns. It helps us in testing hypotheses. It helps us in forecasting, okay? We're able to make informed decisions out of statistics because we'll be able to understand why there's an increased incidence of diarrhea in that community. And then therefore public measures can put in place, okay, so that we halt that diarrhea increase in that community. If you are in Livingstone, you might notice that during a certain season, for example, the season where we have Mosotunya Day of Thunder, ShopRite will highly stock on canned black label. Why is it like that? That's their data analysts analyzed the previous data and they presented the data to ShopRite management to say during this season, people are more likely to buy Black Label than any other beer, okay, or any other type of alcohol. And therefore, they made an informed decision to order more Black Labels. So that's decision making. Forecasting is more like predicting the future, okay? You are prophesying scientifically, but with evidence. So we can use the past data to be able to predict how the data will be or how the results will be. So for example, could be in terms of economy, depending on certain economic activities that are going on in the country, you can predict the inflation rate. So that's forecasting, okay? So applications, what do we use, when do we use statistics? So we can use statistics in almost every sector that you can think of: healthcare, business, research, social sciences, name it. What are the types of statistics? Basically, there are two types of statistics: descriptive statistics and inferential statistics. So descriptive statistics, I like to think of it as my grandmother in the village busy counting goats. How many goats does she have? Of those goats, how many are pregnant? What's the percentage of goats that are pregnant? What is the percentage of male goats compared to the female goats? Okay, so that is descriptive statistics. What you do here, you just summarize the data that you've analyzed, that you've collected. You just summarize. Okay, that's a summary of that data. We don't do any complicated analysis here. And how do we summarize the data? Depending on the type of data. Is it categorical data or is it numerical data? If it is numerical data, we use what we call measures of central tendency or measures of variance. Okay, so what are the measures of central tendency? We have mean, okay, mode, standard deviation, okay, we have median. These are the things that we actually use to actually summarize numerical data. And the choice, your choice of which one you are going to use, whether you are going to use mean, depends on certain assumptions that we are going to discuss in this lesson and in the practical lessons when we start. Now, if your data is categorical, you are going to summarize that using what we call frequencies and percentages. So that we have to know. Sometimes we use visuals. They make life very easy for us to understand the data, okay? Because like I said, just the data itself, it's raw. You cannot make decisions. You cannot draw conclusions from it. You need to make sense. You need to summarize it and present it in a certain way that can make sense. So for example, this, what you are seeing here, is a line chart. This is a line chart. This is a bar chart. I don't know whether it's a bar chart. Yeah, that's a bar chart. So these are visuals that we actually use to summarize data. So they communicate something. We're able to know, okay, the inflation rate here was here, there, it was that, what led to this increase. Then you look at the economic factors, that the economic activities that we are going on. So you're able to predict how it's going to be based on certain economic activities that have been put in place, okay? So that is what we actually call forecasting, okay? Now, inferential statistics is another branch of statistics. What is involved in inferential statistics? So here, this is where we now go into details. We start drawing conclusions about a population based on a sample. The two terms here to take note is sample and population. What is a population? Okay, so this is an entire group of certain individuals. Okay, it could be individuals or it could be objects that share certain similar values. Okay, now it could be, let us assume you want to find out the prevalence of hemorrhoids, okay, or piles, okay, hemorrhoids among pregnant women in Zambia. So your population is pregnant women. That's your population. What is the common value that they share? They are women and they are pregnant. So these are two common values that they share. If you were to collect data on every pregnant woman in Zambia, it is going to be very, very expensive. And it would defeat the whole purpose of statistics. So you are going to select a certain number of pregnant women who are going to represent this population, non-biased. And that group of women is called a sample. And then we're going to collect data from the sample. Maybe we're just going to collect data from certain number of pregnant women from each health facility. Maybe we are going to get 10 health facilities from each province. And from each, maybe we can collect 5 or 10 from 10 pregnant women. So that is a sample. We are going to do the statistical test from a sample, and the results that we are going to use, we are now going to refer, or we're going to infer to a population to say, okay, there is a pregnant women in Zambia have prevalence of, or the prevalence of POWs maybe is 25% in Zambia. Now we are referring into the entire Zambia. That's what we call inferential statistics. And what do we usually use in inferential statistics? We use hypothesis testing, we use confidence intervals, we use odds ratios. We're going to discuss all that when we begin the practical aspect. Now here, this is also very, very important. I want you to pay attention. The types of data or types of variables, it's all the same. So the same thing. We have qualitative data, and then we have quantitative data. If your data, you can do mathematics on it, it's called the quantitative. If you cannot do any mathematics on it, it's called the qualitative. For example, age of a patient. Age of a patient, you can do mathematical calculations on it. You can find the average age, you can divide age. That's quantitative. Now, let us assume gender of the patient. Are you able to divide the gender of the patient? Are you able to subtract the gender of the patient? You cannot. So that is qualitative. So those are also called categorical variables or categorical data. Now, categorical data is also divided into two, nominal and ordinal. Nominal from the word name, gender of the patient, nationality of the patient. The difference between nominal and ordinal is that nominal cannot be ranked in any way. You cannot rank. So there's nothing which is more than the other. For example, you cannot be more Zambian than another Zambian, or you cannot be more of, you cannot say a Malawian has more nationality than a Zambian. That cannot be said like that, because in statistics, nominal variables are unranked, but ordinal are ranked, okay? For example, education level, okay? Education level. Someone who has higher education qualification has more education than someone who has a primary education. So if you can put them in order. Another thing is academic grade, grade 1, grade 2 now, Form 1, Form 2, Form 3 in Zambia. So those that are in Form 3 have more education than those that are in Form 1. So that's ordinal variables. Now, in quantitative data, we have two groups. We have discrete and continuous. Discrete are those where we cannot put decimals, and continuous are those where we can have decimals. Okay, so discrete number of students, we cannot have 2.1 students in class, but we can have 2.1 kg birth weight of a baby, okay, birth weight. So that is continuous. Having understood that, I would like you also to understand that we have two types of variables. We have what we call independent variables and dependent variables. Now, that information is very important when we are going to begin looking at inferential statistics. And I will come back to that so that I can explain in details the difference between a dependent variable and an independent variable. So for now, I'll keep this short. Now, statistical tests that we use. So I would like you to just summarize them into three: parametric test, non-parametric test, and regression analysis. What are parametric tests? When do we do parametric tests? So when our data is normally distributed. What do I mean our data is normally distributed? So, okay, so let me get a pen. Now, and of course, I'll use color blue. Red might be very unusual here. Okay, so if you are to plot your data on an XY chart, or XY plane, your data should look like this. It should spread like this. Okay, so it forms a nice bell curve. Okay, so there we have our X, and then we have our Y. Okay, so it should have a bell-shaped curve like that. That is called normally distributed data. If your data is normally distributed, it's like that. We are going to use parametric tests. What are the parametric tests that we use? We use t-test, we use ANOVA, and Pearson correlation. But sometimes your data is not normally distributed. So how does data that is not normally distributed look like? So it will look like this. It will look like this. This is an XY plane. So when you plot your graph, maybe it's going to go like that. it can be right skewed, okay, right skewed. So this is right skewed. So this data is not normally distributed because this side it goes down, and then at the middle it doesn't spread. It doesn't form this kind of bell curve, but then it's skewed at the right side. So this is where we do non-parametric tests, okay? When the assumption of normality has been violated, we are going to use non-parametric tests. What non-parametric tests are there? We have chi-square test, Mann-Whitney U-test, Spearman correlation. And then, when we are doing this test, okay, these are usually just for association or correlation. These tests, they are usually just for association, correlation, or comparison. They don't tell you anything about the effect size. My lecturer in statistics, he used to tell us that just because you went to switch on the bulb, you went to switch off the bulb, and the light, you went to switch off the switch, okay? You went to turn off the switch of the bulb, and the moment you turned off the switch and the lights went out, does not necessarily mean that you are the reason the lights went out. It could mean that that's the same time that load shedding, power outage came. It could also mean that that's the same time that the bulb had a fault. So correlation, yes, there's an association between you and pressing the switch. So now, how can we ascertain that really there is an effect? What is the effect that you contributed to the lights going out? That's when we do regression analysis. So here it's about the effect size. So remember, correlation is not equal to causation. Just because you found me with a married woman in the bush, okay, and we were the two of us, there was no one else, and my belt was open, does not necessarily mean that I had a conjugal relation with a married woman, okay? That's a correlation. Yes, there's a correlation. There's an association. But is there a causation, okay? Is there a causation? That's why you have to do logistic regression, so that you find what is the effect size that I had a conjugal relation with a married woman, okay? That's regression analysis, okay? And trust me, it's going to be very, very interesting when we go into the details of this. Now, let's look at the choosing the right statistical test. When do we use a certain statistical test? So if we are comparing, it depends with what you are looking for. Are you looking for the difference? Are you looking for an association or a correlation? Okay. So if you want to compare between two groups, you can use a t-test for parametric test, for well-distributed data, and Mann-Whitney U-test for data that is not normally distributed. So this is a parametric test, and this is a non-parametric test, okay? This is a non-parametric test. So for two groups, if you want to compare means, so this is mean comparisons, okay? T-test compares the means of two groups. For example, you want to look at for example, the question could be, what is the effect of a drug, a certain drug, let's say atropine, in males and females? If you give atropine to a male and you give atropine to a female, what will happen to the pulse, okay? Is there a difference in the pulse between the two groups? So the two groups that you have is males and females, okay? And what you are applying there is atropine, a drug, okay? So you are going to give the two patients atropine, and then you are going to check the two groups of patients, males and females, and then you are going to check the mean pulse after a specified period of time, and then you are going to use a t-test to notice whether there is a statistical difference between the two pulses. The other example that I can give is a common example where you want to look at the size of doctors and teachers. Is there a statistical difference, okay? People could say, no, doctors get more. But in statistics, we don't like to put it like that. We want to see, is there even a statistical difference between the salaries of doctors and teachers? So you can use t-test. If the groups that you are comparing are 3, you use ANOVA for data that is normally distributed, the parametric test. So this is the parametric test. And if your data is not normally distributed, you're going to use Kruskal-Wallis. So ANOVA and Kruskal-Wallis are rarely used in academic research. Mainly you're going to use t-test or Mann-Whitney U-test. And if you're looking for relationships, we use correlation, okay? Correlation, and also Spearman. So there's Pearson correlation and Spearman. These are statistical tests that we use for examining the relationship between two variables. So Pearson is for normally distributed data. So this is a parametric test, and Spearman is a non-parametric test, and you know when to use each one of those. And then for associations, is there an association between having intestinal obstruction, okay, and the type of food that you eat? So you are comparing two categorical variables, you are going to use a chi-square. If the groups that you are comparing are two categorical variables, you are going to use chi-square test. Now, just choosing the statistical test is the first step. And then there is another part, ensuring that your statistical tests meet the assumptions. The assumptions are not violated. So if you want to use t-test, assume your data is normally distributed. Homogeneity of variance also has to be met. The assumption of homogeneity of variance, meaning that the spread of the data between two groups should be the same, okay? The spread of your data should be the same, assuming, let me put it like this, okay? This is the oceans, two oceans, and then there's a wave there that goes up, okay? And then there's another ocean, and then there's a wave that goes up, okay? So these waves, they should be the same in two groups. That's what homogeneity of variance mean, okay? So the spread in the two groups should be the same. That's homogeneity of variance. And don't worry if you don't understand it now. For now, just believe that this is the way things are. And when we begin the practical part, you're going to understand how to do this. It's simple, trust me. And then for chi-square, the expected frequency in each cell should be at least above 5. And then for correlation, you have to meet the assumption of linearity. For correlation, you have to meet the assumption of linearity. What does this mean? If you are to plot on the XY plane, let us assume you are looking at age versus blood pressure. Age versus blood pressure, if you are to plot. So as the age of the patient increases, maybe as the blood pressure, maybe I should have put age this side. I should have put age this side, and then blood pressure this side. So that as the age of the patient increases, the blood pressure also the mean arterial blood pressure should increase, okay? Should increase in a linear pattern like that. So for correlation, you can only do correlation test if the Pearson, what is that? The Pearson, is it the Pearson? Yes. The Pearson correlation test can only be used if your data is spreading in a linear pattern. And if it doesn't, you're going to use the other one called Spearman correlation. If your data is linear, you use Pearson. If it's not, you use Spearman, okay? And the other thing for logistic regression is multicollinearity. So your variables shouldn't be well correlated. They shouldn't be very related. An example here could be, let us assume you want to look at the association between metabolic syndrome, okay, metabolic syndrome, and the BMI of the patient. So the variables, the independent variables that you have is BMI, okay, you have BMI, body mass index, and then you also have weight of the patient, and then you also have height of the patient, okay? You have height of the patient. Now you are going to notice that for you to calculate BMI of the patient, you need weight and height. So these three variables are very related, okay? This is incest. That's how I like to put it. It's not allowed in regression analysis. You can imagine, even in statistics, okay? It's more like asking the same question to two people who are going to give the same answer twice. So no, it's not allowed. So multicollinearity, the assumption of multicollinearity doesn't have to be violated. You have to check that. So incest is not allowed. It's not allowed in regression analysis. Okay, so that's the assumption. And you are going to see how we actually check for the assumption of multicollinearity. Now, SPSS and R Studio are the tools that we are going to use in this course. Now, what are the advantages of each? SPSS is user-friendly, okay? It's user-friendly. It has a very good graphic user interface base, so it has a good graphic user interface base where you're able to see nice charts, pictures, and so on. And then it's ideal for quick analysis and reporting. Okay, so it's ideal for quick analysis and reporting. You don't need to know any script here. You don't need to know any coding here. Just simple and straightforward. Okay, just drag and drop, and you're done quickly and fast and efficient as well. Okay, now there is another statistical software called R. It's called R. Okay, the statistical software called R. So R is a programming language. R is a programming language. We like to call it the language of data science. Okay? Previously, I learned how to use data. And then I diverted to SPSS, and now I use R. Why? So this is script-based, so you need to know coding here. It's highly customizable, and that's the reason I use it. It's highly customizable. And now, with the introduction for artificial intelligence, you can do almost anything, even when you don't know anything. That's R Studio. And it's ideal for advanced statistical modeling. So what is the main difference here between R Studio and SPSS? Let us assume you want to buy furniture in your house. So there are two things you can do. Either you can go to the carpentry, okay, to the workshop where there's a carpenter, and then you can tell the carpenter to say, I want you to make for me a furniture that looks like this color, it should have this feature and that feature. I want it like this. That is R. Or you can just go to Fun City and pick one of the furnitures that have already been made. That is SPSS. That's the difference. I hope that makes sense to you. Now, this demonstration that we are going to go is going to cover step-by-step data entry, how to run descriptive and inferential statistics, and how to interpret the results. Congratulations, you've come to the end of this boring lesson on data analysis, on introduction to statistics for data analysis, okay? The key takeaways, just remember the types of statistics. We have descriptive and we have inferential statistics. We have categorical and numerical variables, which are further divided according to the type again. Remember the statistical tests. We have three main statistical tests that we use: the parametric, non-parametric, and regression, okay? And then, and also remember the assumptions for each, but you don't necessarily have to remember the assumptions. When we begin into details step by step, I will take you through again those assumptions and how to check those assumptions. So the next lesson will begin introduction to SPSS. That's what we are going to look at, just introduction to SPSS. So we're going to look at the interface of SPSS, how to import data, and basically maybe how to clean, just a few things. I hope you found this introductory lesson very helpful. I wish you the best, okay? I put in so much so that I summarize this course for you. For me to learn this data analysis, the time I graduated from medical school, I didn't know how to analyze data. I invested so much time and money and resources into learning the skill of data analysis. I wasted time, like hours. It should have been more than 1,000 hours just learning how to analyze data. And I wish someone told me to say I should have just focused on doing than learning. So I urge you, after this course, instead of learning more, you should start doing. You should get projects and start doing. So that when you encounter a problem, when you're doing statistical analysis, then you can now go on YouTube, you can ask a friend, you can go on Google, you can go on artificial intelligence and ask for help. Because now that's when you learn the practical part of data analysis. So thank you so much. Bye-bye and God bless.